Welcome again. We are excited to have a discussion about drones in research and education and the many ways they're being used here at UCSC. My name is Michael Matkin. I am the Executive Director of CITRIS and the Banatao Institute here on campus, and I'll tell you a little bit more about what that organization is. But first, I would like to introduce our illustrious panel for the evening. So, first of all, Professor Michael Loic, he is a professor in the Environmental Studies Department. His work focuses on ecological impacts of climate change and developing new technologies to reduce greenhouse gas emissions. His research has taken place in desert, montane, grassland, forest, and tropical ecosystems worldwide. His 2017 paper on electricity generating greenhouses was covered by Newsweek and over 125 other news sites. Professor Loic serves on the steering committee of the International Drought Experiment and is the chair of the Physiological Ecology section of the Ecological Society of America. So we're very pleased to have Professor Loic join us. We also have Professor Steve McGuire here with us, and he just managed to get in. We're excited to have you here, Steve. Thanks. He is a professor of electrical and computer engineering. His lab is the Human Aware Robotic Exploration Group, which the acronym is HARE, and they explore human-robot teaming in the context of field robotic applications. Prior to joining UCSC in 2020, Steve earned his PhD as a NASA Space Technology Research Fellow from the University of Colorado at Boulder in aerospace engineering sciences. He's a former Marine helicopter pilot and has been part of several top-level field robotics initiatives, including the DARPA Grand Challenge in 2004, the Google Lunar X Prize, and the DARPA Subterranean Challenge, where his team took third place just this past year. So that's it was a huge win. We also have Dr. Becca Fenwick. She's the director of the CITRIS CIDER program, which we'll learn more about. She leads the research and industry partnerships part of that program, along with many other things. She's formerly the director of environmental information and technology for the UC Natural Reserve System, and she's been based here at UCSC since 2015. Over the past 10 years, she's developed the NRS Environmental Information and Technology Program, where she created a statewide network of weather stations, environmental sensors, and drone monitoring program that's now an essential part of the new California Biodiversity Network Sentinel site collaboration across the entire UC system. She received her PhD from the Scripps Institute of Oceanography in marine geology and geophysics. And the fourth member of our panel is Dr. Justin Cummings. He is the Associate Director of the CIDER program, where he runs the student programming and training parts of that program, again, amongst many other things. He's the former mayor of the city of Santa Cruz. He currently serves on the Santa Cruz City Council, and he's running for 3rd District Santa Cruz County Supervisor as well. From 2015 to early 2020, Justin co-created and served as the founding director of the UCSC Doris Duke Conservation Scholars Program, which prepares the next generation of diverse conservation leaders. And he received his PhD from UCSC in 2013 from the Ecology and Evolutionary Biology Department with a designated emphasis in environmental studies. So very pleased to have everyone join us today. So here they all are. So I'm going to start with a very quick little explanation of what CITRIS is. We all have CITRIS connections that we'll talk a little bit about as we go along. So the acronym of CITRIS is the Center for Information Technology Research in the Interest of Society. We're kind of an interesting UC organization, and our mission is to create IT solutions for society's most pressing challenges. So really tech for social good. We look to fund and support projects that provide social benefit. We are unique in that we are based on 4 different UC campuses. So here at UC Santa Cruz, we're also have a headquarters at UC Berkeley and a center at UC Davis and at UC Merced. So we do a lot of collaborative work across those campuses, and we also run a number of programs that support interdisciplinary research for both students and faculty here at UC Santa Cruz. So I won't belabor that. I encourage you to go look at our websites to learn more about the organization. But today we're going to be talking about drones. And specifically, we're going to be talking about the 4th box here, aerial drones. But it's important to note that there are many other kinds of drones. Pretty much any place on the planet, drones can go, both underwater and above, on top of the water. And there's a lot of drones being developed for terrestrial use. We see one here delivering food, and they also do amazing things like defuse bombs. And
hey, Michael, we
yeah,
can't see your screen if you're sharing screen.
Oh well, let's fix that. There we go. How's that? Great. So yeah, now you get to see the little pictures. Here is the food delivery drone. This is the aquatic drones we have. There's these are both Silicon Valley companies that have developed really interesting platforms to do above and below water research, and of course aerial drones, which is what we're going to be talking about today. So aerial drones, you've probably heard the terms UAV or UAS. That stands for uncrewed or unpiloted aerial vehicles or aerial systems. And the sorts of drones that we use on campus here range from, we see in the top here, small platforms that fit in the palm of your hand, all the way up to larger drones. And this one down here, we see it being flown by one of our students in Steve McGuire's lab. And that's a pretty sizable piece of equipment. Certainly capable of carrying a lot of sensors and doing some pretty prolonged field research. So that is a little bit of background on what we're going to be doing. And we're going to start off by having each of our panelists give us a little information about their work and their experience with drones. And let's start with Becca. Whoops, I think you're still muted. There we go.
There we go. Great, thanks, Michael. If you can, are you going to be driving the slides?
I will drive the slides.
Excellent. So welcome everybody. One of the programs that Michael's mentioned that we've been working on for a better part of a year now is called CIDER, which is the CITRIS Initiative for Drone Education and Research. So if you want to go to the next slide. Our mission is to bring together diverse students, researchers, and industry partners from a variety of sectors to fuel research and innovation and develop a diverse drone workforce. This is something that we all feel relatively passionate about, and it's been super fun getting it up and started. The CIDER program itself has sort of 5 legs to the mission, or 5 parts to it. Pillars of the program, as it were. The first one is support for underrepresented students. Justin will tell you more about this in a moment, but we all feel really passionately that the drone workforce and drone industry at the moment is, as most tech sectors are, very white and very male. And so it's very new. So we feel that we should be able to influence change and make that more diverse from the very beginning. And that starts with getting students interested in it. So support for underrepresented students. Education and experiential learning for these students. So we're looking at developing a drone minor for UCSC, working across all of the disciplines and really putting experiences in the hands of the students. So getting hands-on drones, getting them outside and getting them learning by doing. What I'll talk to you briefly about, commercial contracts, industry outreach, and research support. Next slide. So in research, drones are used for a variety of things, but specifically in research, they fill a gap between data that was available from planes and helicopters, which is sort of on the 10 meter per pixel, sort of 1,000 hectares scale, so like a site or research area. There was a gap between that and the data that you can get from sensors on the ground at weather stations. And so drones fill that gap. They can fly, small plots to large plots. You're looking at about 100 hectares per plot with a resolution in the centimeter scale. So that's like being able to see individual leaves and branches on plants. Next slide. And so what we do is in our research support is we work with people across the sort of interest spectrum, looking at lots of different types of research. But a really good example of something that we've done in the last few years is reacting and making use of changes in the environment. So in 2020, as we all know, there was a large number of wildfires across the state. And for better or worse, they actually burned across several of the UC Natural Reserve sites that we'd been doing drone research on. So we had, this is down at Big Creek in Big Sur, one of the UCSC Natural Reserves. And the site that you're seeing in the middle of the screen there, we flew it several times in 2018 and 2019, and the site burned in 2020. If you click once, Michael. We were able to go down there and fly right after the burn in November. And so we collected data of the impacts that the fires had at the time. Some of the images on the left there show that melted sensors, which happened during the fire. And then we were able to go out again 6 months later, if you click one more time, Michael, and fly again in June of the following year, where we start to see the vegetation come back, and we can actually quantify the landscape recovery with using the drone data and getting large aerial extents of this information. The picture on the bottom left is of some of the redwoods coming back on the property, which is absolutely fantastic. So in the process of doing this, you're like, we work with different faculty in these different departments. If we go to the next slide, some of the support that we offer are sort of research concept development. So how you address the question that you have as faculty members. You may have to click through these bullet points, Michael, or not. So we look at research concept development. We will help you decide what drone platforms you need to use. We can help train you, use those platforms, train to process the data, and we can also rent out equipment. So this is a small selection of the drones that we have available at the moment. And those are available for faculty and graduate students to rent if they've had the training. And then if that's not something that you're interested in doing, but you're just interested in the data, then we have staff on hand who can be contracted to fly the data for you, potentially process and analyze it as needed. If you click through. This then leads into the contracting side of the equation. So Justin's going to tell you in a minute about the training program for the students, but the end product of that is that we have FAA licensed undergrads who are being taught how to use drones, and they then can work for us on these contracts, either internally with researchers or externally for different agencies and companies. And in the process, they get paid for their time, which is fantastic. They also have work experience, and then they're able to leave their undergrad. Once they graduate and leave UCSC, they have real world experience and flight hours under their belt, which will help them get really cool jobs in the future. These pictures are just from work we were doing a few weeks ago, flying some roof inspections and building inspections for the UCSC facilities on campus, which was really quite interesting and fun to do. Next slide. Our other part of what I look at on this program and sort of work through is the industry engagement part of this. So we are surrounded by, or right next door to Silicon Valley, and there are some amazing companies there and also globally who make drones, build them, work with data, build sensors for them in a variety of ways. And so we are reaching out to these companies, and we're forming partnerships and engaging with them around student internships, potential research partnerships. We've done some product testing, some development of case studies for different companies, and looking at getting product discounts so we can use their equipment and their software into the future. And we're continuing to build these partnerships, and really excited about where these can develop to. Next slide. And then I will pass it over to Justin so he can talk to us about the support for underrepresented students and the education and experiential learning for the students.
Great, thanks, Becca. So my name is Justin Cummings. I'm the Associate Director and one of the co-founders of the CITRIS Initiative for Drone Education and Research. As Michael mentioned earlier, I have a PhD in ecology and evolutionary biology from UC Santa Cruz with a designated emphasis in environmental studies. A lot of my dissertation work focused on tropical forest restoration, so understanding how trees used for restoration suppress the regeneration of invasive grasses. I've also conducted climate change work in the Everglades, looking at how changes in climate influence the uptake and release of carbon in the Everglades. And so a lot of what I've done over time has been on vegetation or ecosystem management and ecosystem monitoring. And then in 2015, I became the founding director of the Doors to Conservation Scholars Program here at UCSC, which really focuses on increasing diversity and conservation. And knowing that oftentimes students who come from backgrounds that are underrepresented in conservation, low income, first in family, a lot of times these students don't have a lot of the support networks, and they don't have the financial means to be involved in internships during the summer. And so the Doris Duke program helped provide this training to students by paying students to participate in a 2-summer experiential learning program where the students in the first year got hands-on field research training. And then in the second year, we're able to work with conservation organizations and through internships that were funded. And this, in part, has kind of set the stage for the CITRIS Initiative for Drone Education and Research, where our objective is to, again, target students who are historically underrepresented in STEM and provide them with paid training experiences so that when they get out of college, they're competitive for the workforce. And while they're in these training programs, they're not financially constrained. Next slide. And a lot of what's driven this work is the fact that, similar to many fields in STEM, there's not a lot of diversity in the fields of aviation. And given that the drone industry is in its infancy, it's really critical that at the outset, we're targeting people who are traditionally underrepresented in STEM and aviation and really trying to get them into the field. This graph looks at demographics and percent composition of people. And what we see is that based on the 2020 census, the US population is about 57% white and 42% people of color. But when we start looking at the aviation industry, in particular, aircraft pilots, flight engineers, what we can see is that this blue, the third blue bar on the left, 92.7% of the industry is currently white, with 7% being people of color. And when we look at that same demographic for male and females in the United States, we have a little bit more of women than men, so 51% as female as opposed to 48.9% male. But again, when we look at the industry, the aviation industry, for these two fields is about 93% male and 7% female. So there's obviously a large need to try to, change the ratio of men to women and people of color to white to make it more reflective of the US population. Next slide. So what we've done for education, we kicked off our 2022 pilot training program during winter quarter, where we recruited 20 students from campus and had them participate in a 9-week training program where part of their training was an FAA study course. And actually, I'll talk about that more in a sec. So with a pilot training program, we are working to develop a workforce development program. And in addition to that, we are in our 6th year of hosting Drone Camp, which is a week-long workshop. And this year it will be offered both virtually and in person at CSU Monterey Bay. And we will provide the link to that. So if you want to learn more about Drone Camp, you can click on that link and learn more. But it's a week-long workshop on the use and application of drones, how to do mapping, different types of hardware, software. But we encourage you to check out the website for more information. Next slide. And so the pilot training program, we had FAA test prep, which Professor McGuire was able to help us teach. We introduce students to the use and application of drones. We cover safety. We provide them opportunities to practice flying, mission planning, data analysis, and we have industry engagement with the students. So we had a panel where we invited people from who are entrepreneurs and also working in different sectors in the industry to tell students about what it's like working in the drone industry and how to get jobs. Next slide. Oh, and if you can go back, I'll just say one more thing, is that this year at the conclusion of our program, we've had 12 students who passed their FAA test thus far and now have their FAA Part 107 licenses. And as Becca mentioned, a number of these students have already started working on campus, helping us as we're beginning to conduct surveys of buildings, and hopefully they'll be working with faculty researchers to help them fly as well. And we do have one student who is waiting to hear back, but might be also getting a job with a company named Skydio. And so very happy with the first round of this program. And with that, I'll turn it over to Steve.
Thanks, Justin. Next slide. I think so. This is great. My relationship to CITRIS. CITRIS is currently a sponsor for one of my projects titled "Online Plant Disease Detection via Hyperspectral UAV Imaging." That's an agricultural application. And next slide. So the whole point of this is to identify latent plant diseases. What we see on the left side is a disease called chocolate spot. And on the right, we have a disease called fava bean rust, both of which are destructive diseases that reduce and cause problems for farmers, especially for farmers who are interested in organic methods that don't require herbicides. The challenge that we're trying to find is identifying these diseases. By the time they reach this point, where you can visually inspect it on the ground, it's really too late to do much about it, especially since detecting this requires a person to see it on the ground. What we're trying to do is to use the plant's internal response. That is, the plant knows it's sick before it shows visual evidence. We can use the plant's internal response in order to predict when a certain patch of field is showing signs of stress, whether that stress comes from infection or otherwise, so that we can dispatch those human resources to go check it out, see what's going on, and potentially treat them in a way that is compatible with the farmer's goals. So to implement this project, we're flying drones. Next slide, please. And this is a picture from one of our first field tests where we have our pilots. The gentleman who is standing in the blue jeans is one of our graduates from the CIDER program, who's my pilot in command for this project. And the other two younger gentlemen are part of my research group. And this is aboard the CAFS farm that is on campus. And we are flying tomorrow at 9 in the morning for another iteration of our field exercise. I believe there's some sick garlic that we want to look at. The premise being the greater impact of this work is it's really opening up the value of being able to detect these diseases much faster than would otherwise be possible if we had to dispatch people to inspect the plants. A drone flight can cover hectares much faster than human field scouts can, and give us these insights that, hey, we have latent problems brewing. The plants know they're stressed, and we would like to figure out why as soon as possible, so that we can treat in the most concentrated and least destructive way possible. And this is just one area where I'm using drones. I also have other research projects in the works where we're working on problems more akin to the field robotics side, in cooperation with other faculty here at UCSC, where we're deploying ground robots to deploy soil sensors and test new communication networks and do all sorts of fun stuff with robots running around. And but that really is a good summary of my UAV work. Also for CITRIS, I'm using my hat as a FAA flight instructor to help out with the Part 107 class. So it's not like I'm not just a professor who happens to be also a commercial pilot. I also have that instructor certification, and that's worked out really well for my lab in particular, because now it empowers my students to be able to conduct research without having, and they can conduct research independently and progress our projects a lot faster. And that's the short overview. Thank you.
Excellent. Thanks, Steve. And let's turn it over to Michael.
Thanks, Michael, and thanks to Steve, Justin, and Becca for setting the stage to make it easier to describe the work that I'll talk about here. So one of my several research projects is conducted in Eastern California, where our Sierra Nevada snowpack is an important source of water year-round for agriculture and for urban and domestic uses. And for the past 20 years, we've been studying the interannual impacts of snow depth and how it impacts ecosystems in this area near the Mammoth Mountain ski area. Caltrans years ago built a series of snow fences along the highway here that create a repeatable pattern of snow depth increase, which provides us with a 60-year experiment of snow depth changes that are that we use as analogs of what the future climate might look like, with both increases and decreases in snow depth associated with the snow fences. In the image we see right here, I have deployed a couple of sets of instruments that are measuring photosynthesis of the shrubs at this site, and also measures the water that is lost from the shrubs in the process of transpiration, and those things go on at the same time. So we've been measuring year in and year out how much snow falls and how much water soaks into the soils, how much water is taken up by the shrubs and trees and the grasses and so on at this site, and how much carbon they take out of the atmosphere and incorporate into new growth and reproductive effort, making seeds, and who lives and who dies in this ecosystem, in this plant community, year in and year out for 20 years now. And so our work with CITRIS, if Michael, you could go to the next slide, will be to utilize various types of sensors to complement the work that we've been doing for the past 20 years. On the one hand, we hope to use some radiometric methods to be able to understand the amount of photosynthesis that's going on at the canopy level. The green boxes that you see in the image can measure the photosynthesis and water loss of shrubs from individual leaves or groups of leaves, but using UAVs with appropriate sensors allows us to make these similar kinds of measurements at a much larger spatial scale, as Becca introduced when she was speaking earlier. And there are various aspects of the signal that bounces off of leaves that can be utilized to tell us about photosynthetic behavior, as well as the presence or amount of water in plants, and whether the plants are undergoing stress. Now, when plants are photosynthesizing and they lose water, there's a little bit of heat that travels with that water as it evaporates from the leaves. And so we can measure the heat using infrared sensors. And this year, working with Becca and Justin's students, we intend to couple these on-the-ground measurements with the drone measurements, including a ground-based ground truthing spectrometer that you see in the photo in the center, which is a Internet of Things enabled sensor that will allow us for ongoing real-time measurements of photosynthesis that can be connected or coupled with the measurements being collected with the drone, but left out there when the drone's not able to fly for us. And so that's one example of some of the ways that we are using technology to help answer questions about climate change and changes in snowfall at this site. Thanks a lot.
Great, thank you, Michael. And maybe just a quick follow-up question: how, if you didn't have access to drones, how how would that research have moved forward? How would you go about doing a study like that if you didn't have access to drones? Just out of curiosity.
Well, we would have a missing spatial element. So as Becca noted, there are different kinds of technologies for different spatial or temporal scales, and so we could use satellites. And you can see in this image that whole sort of area in the background of shrubs with some trees mixed in is about 1 satellite pixel for something like MODIS. So not a lot of detail that can be picked up. And like I said, we can make measurements of individual leaves, but we can't, we could spend all day walking back and forth with those boxes and measuring individual leaves, but we could never make the same kinds of measurements or on as many leaves as the drone allows us to capture thousands and thousands of leaves in one flight. So it really both speeds up and provides an entirely different level of perspective that, until a few years ago just wasn't possible, sort of in between the hands-on measurements and the satellite level measurements. It's really exciting.
Excellent. Yeah, very exciting. We're excited to see the results of both these projects. So let me stop sharing the screen now, and we can get a little bigger on our screens. And let me just open it to a question. Tell people about other projects that you know of that you think are using drones in an interesting way. And let's start with Becca.
I think one of the ones that I'm really excited to learn more about is actually one that you mentioned earlier, Michael, is the ocean going drones, and looking at how they're being used to map the seafloor and to understand better the processes that are happening. The ocean is often regarded as one of the next frontiers, right? There's places that we know less about the ocean floor than we know about in space. And so having these drones and the ability to send them out and have them collect data all over the planet is super exciting to me.
Great. Yeah, me as well. And I think it's notable that, when we started the CIDER program here, we specifically called it the Drone Education and Research Program, not the UAV Education and Research, because we recognize that there are those other exciting drone technologies that will eventually reach towards. But aerial drones are so accessible right now, and the price of them has come down, and the advancement of the technology has made them very easy for to be used in research as well as in education and at home. A lot of people have drones. What about you, Justin? Any projects that you find notable?
Sure, yeah, and I'm gonna share a link in the chat. But there's a member of the community here in Santa Cruz. His name is Giuliano Khalil. He works for, he started up a company called Virtual Planet Tech. And what they've been doing is that they've been taking drone imagery along with animation and data on predictions of climate change. And they've been using this to create simulations, like virtual reality simulations of what can happen to different communities under different climate change scenarios. And kind of wearing both like my government and drone hat, they actually did one of these for the city of Santa Cruz, where they can show under different scenarios of climate change what areas along our cliff and in our lowland beach areas will be flooded and what it can look like. And they've done this in many other cities across California, and also they've done it with fire. So it's a really good way of incorporating climate change research with drone imagery, virtual reality, and tech, and really using that for scientific education around how communities can be impacted, which also can drive policymaking around what are we going to do to help mitigate the impacts of climate change. And so it's a really cool way that people have been using all sorts of data, but drone imagery as well.
Very cool. And Steve, anything
Yeah,
that you want to highlight?
if I can if I can chime in here. So Michael had mentioned in my intro, the DARPA Subterranean Challenge, which was for a looser definition of the word drone to mean basically anything that's not where there's less human supervision, basically anything beyond remote control. Sub-T was a great experience for pushing the field because one of the ways that the challenge was built was you're given a single human that has to sit on the outside, and you have a portal that you send the robots in, and that's that. And you have to build the entire infrastructure for the robots to explore, perceive, understand, map out what's going on. And the mission that was used as a placeholder mission is that of a scavenger hunt, which you can think of as a survivor type of search and rescue sort of scenario, where you have to go into this unknown environment and find certain things of interest that you then report the location of. And you can think of it as a research, search and rescue rather scenario, where you're providing the robot team is providing a high level information so that you're not necessarily risking humans to go in and do the base mapping to figure out where the important things are. So that by the time you get the humans involved, you have far better information to work with, you're reducing risk at the end of the day. That sort of scenario is a great example of sort of the dull, dirty, and dangerous tasks that we build autonomous robots to explore every day. I should have mentioned, actually, I just had a contemporary project start up in my lab. An undergrad who has certain connections is connected with a humanitarian relief project to build drones to send to carry aid and to do aerial imaging in Ukraine. And the idea of using drone or autonomous robotics, particularly for disaster relief, where you need that bird's eye view of a much better resolution than you're going to ever be able to get from a satellite. And you can do it with an asset that's not crewed, which means that, yeah, if you lose it because it soaks up with volcanic ash or whatnot, you're not going to be thrilled, but it's also not that big of a deal. And lets us do monitoring of these emerging situations by reducing risk and keeping those air crews out of the harm's way, while still enabling a much better situational awareness for further effort to monitor the development, to see what other actions need to be taken. And I mean, we just had the example of monitoring the Cal Fire or the CZU fires locally. The ability to there are places you don't want to send a crew, that you can send a drone, and yeah, if it gets toasted, oh well. And that to really help you understand fundamental questions. How is this phenomenon spreading? What do I need to worry about next? So there's all sorts of applications of anywhere in those big three categories of dull, dirty, and dangerous.
Those are great examples, Steve. Yeah, really exciting work. Michael, anything that you would like to highlight?
Yeah, I think maybe Steve touched a little bit on this earlier when he was speaking, but you know, I'm a sensor head from way back, and I sort of have always thought of drones as being outstanding sensor platforms. But I think what's really interesting is taking them beyond just looking down on things and being able to do things. For example, maybe broadcasting seed for restoration projects, post-fire restoration, or other kinds of proactive kinds of activities on the ground or in the air, as it may be, that could be really useful in terms of assisted migration, for example, in the future, as ecosystems, plant communities have to migrate into new habitat, where it might be cost prohibitive to have a lot of humans doing this kind of work. So that's one of the things that comes to mind for me.
Yeah, those are great. It makes me think, I think one of my favorite projects is Roxanne Beltran and in Dan Costa's lab. They're doing that project where they fly the drones over the elephant seal populations, and they have an algorithm that allows them to very accurately estimate the weight of the animals. And, you know, previously it was they would have to tranquilize the animal and lift it up on a sling and weigh it that way. So it's what a huge development in field research. So what about the direction that the drones are going? Like, as they develop, is there something that you're excited about, you're anticipating as an application in research settings or education settings? Let's start with Steve this time. I see he looks very excited.
So one of the things that I'm really looking forward to, there's a great the democratization of drone technology is a really big plus. What is available at a consumer or there's like the military price point, which is no price, which is mission first, price is irrelevant. Then you have government price point, which you start caring how much it costs. And then you start getting into things like corporate, research, and personal. And we see with the rapid rate of semiconductor and sensor development, we're starting to get a lot more advanced technology that's within the range of both personal and research grade sensing, both in terms of quality of sensing and quantity. So for example, the hyperspectral imaging project I'm working on, one of the hypotheses we're testing is what we can do with a $150 sensor as opposed to the $5,000 sensor, and to see whether we can achieve reasonable results with a much cheaper sensor that opens up the democratization of drone technology. And that's probably one of the big, you could make the same argument for compute, sensing, communications, you name it. The commoditization opens up whole new avenues that wouldn't have been practical even just 5 to 10 years prior. I know one of the projects that I'm looking forward to doing is doing a marsupial operation where I have my ground vehicles launching drones and providing ground support for the drones and having them work together to accomplish a mission where the drone accomplishes the viewpoint that the ground vehicle could never hope to, but the ground vehicle can run for hours at a time and not be limited by a 20-minute flight time, to have the two be able to work together. The democratization also presents unique challenges for the community, as we now have the challenges of bringing in new members of the aviation community into the fold, and how to sort of imbue the ethical standards of conduct within that new population, which I think the CIDER program is doing a great job of. It's the cost to entry is so low, but there's minimal guidance, minimal number of programs of how to effectively use this in a way that respects, for example, the property rights, privacy, and safety, really, of the national airspace system. And those are lessons that we're able to teach and reach these new users who are going to be in positions to become productive members of that community and shape policy discussions going forward. And so that's where I really think it's not just the technology, but the fact that we're engaging in these training programs is really going to be, it will make a difference, both for us and for other places around the country that are trying to solve the same kind of problems. We're certainly not alone in this.
Yeah, those are great points. I won't put anyone on the spot, but anyone else, if you have something that you want to jump in and talk about what you're excited about moving forward. Yeah, Becca.
Well, one of the other projects that Justin touched on that we're working on is workforce development, and sort of seeing how the drone technology can be used across the spectrum in all sorts of industries. And one of the target areas that we're starting to look into more is sort of agriculture. And there's a massive labor shortage in agriculture. They just don't have the people who can actually do the work. And so this is where the democratization of the technology comes in. The price point has come down to such a low point that we can now start to use these drones as tools to facilitate agriculture and have targeted fertilization and targeted watering programs that increase yield. And then also looking at the automation of picking crops and doing the weeding and targeting all sorts of different treatments. And this hopefully will fill that gap and help bridge that gap between when we had large labor forces that could just come in and do everything by hand to where we're now don't have that, and how do we provide security around our food source and get those crops growing and getting them picked.
Excellent. Thanks, Becca.
I think one last thing I'd like to just toss in real quick is some of these hybrid systems where you have sort of lifting technology that's working, for example, with like firefighting equipment that's based on the ground, and they're pulling hoses up to spray water from certain heights. And so just some of the ways that those technologies could be used with other kinds of needs in ground-based hardware at the same time.
Yeah, that's really exciting. And there's some, there's a local company, Parallel Flight Technologies, based down in La Selva Beach, that they're developing an amazing hybrid platform that has a gas engine as well as electrical, and they can lift up to 100 pounds and fly that for several hours. So a tool that can be used to resupply in fire lines, and just so many applications. So really exciting to see that that development happening. So what about, I know we're getting relatively close on time, and we have one question from the audience that we can direct to Justin. Someone is wondering, this is a bit in the weeds, but when is the next pilots and training program going to be held? And what qualifications or requirements are there for being accepted to the program? Are there certain majors or backgrounds that will be prioritized?
Great, yeah. So this past winter quarter was our pilot launch, and so we're still kind of assessing that, but we're going to be hoping to have another cohort, if not this fall, then in the next winter quarter. And in terms of what students need in terms of qualifications, we actually accept students from all majors. We ask that students are in good standing, but it's not a requirement. I think we really want to make sure that students who are coming into the program are in good standing, in the sense that they're not on academic probation, because if that's the case, they really need to focus on classes. But we have an application process where we ask the students a series of questions around how drones will fit into their career trajectories. How do they see themselves helping to diversify the drone field? And based on those answers and letters of recommendation, we try to then select students, based on their passion for wanting to go into this field. And again, we don't have any major requirements, because we understand that drones are being used for so many different things. There are students who are interested in the software design. Some students are interested in the mechanical design and engineering. And then there's other students who are interested in flying drones for the cinematography or art. And then again, we have students as well who are interested in flying drones for ecosystem monitoring, conservation. So the idea is that we want to bring in students from different fields, because when we can demonstrate the application and the uses of drones, and having students from not only diverse racial and ethnic backgrounds, but also diverse disciplines, it provides an opportunity for students to really start coming up with new thoughts and then collaborate across different disciplines to start thinking about ways that we can use drones that maybe we're not using them for currently.
That's excellent. Thanks, Justin. Yeah, and one thing that I just want to reiterate is drones are being used or will be used across campus, every discipline. When we started planning the CIDER program, we sent a survey around to faculty, and we got 50 results from people across every discipline. People in archaeology and anthropology were doing field studies, going out, flying over and finding ruins in dense remote jungle. People in sociology doing field studies. People, obviously, as Justin said, people in art doing cinematography. So, the faculty want to be doing more research using these tools, and students in all those areas as well have projects and interests that will be supported by understanding how to use these very versatile tools. Sorry, go ahead, Justin.
If I could say one more thing that kind of ties in to this topic as well. You know, there was one student, and this also ties into the previous question, who had applied for the program and was saying, like, you know, one thought is, you know, in areas where there's been warfare and there are potential mines, using drones to detect mines on the ground. And that was something that, you know, I think that we don't really think about here in the US, but for people who might be in countries where there's still areas where there's, you know, mines deposited, you know, being able to send drones out to find those mines rather than humans, whether they're aerial or terrestrial, is something that could be, you know, extremely beneficial for helping to mitigate those sites.
Yeah, another very important application. So we have 5 minutes. I'm going to ask one last question, but again, everyone, we encourage you, if anyone has any other questions, just drop them in the Q&A. And I also wanted to mention that we are having a flight demo this Saturday, 10 a.m., right below the music recital hall over near the Great Meadow. And if you're interested, you can just show up. We'll be there. We'll have a bunch of our equipment. You can look at it and touch it, and then we'll actually have a number of our smaller drones, and you can grab a controller and learn to fly a drone. So if you need more information, you can drop a note in the Q&A, or you can I'll drop my email address in the chat as well. So you can just reach out to me directly. So the last question: is there any advice that you would have for someone who's interested in entering this field, either as a student or someone out there who currently has a job and would like to apply drone technology to what they're doing? And what are the most promising areas that you see for impact? And I'll just open it up. Whoever wants to start.
I'll jump right in. I think the most important thing that I see in terms of getting into drones is honestly just enthusiasm and, you know, the willingness to learn. And those seem sort of very intangible, but they're just so important in sort of any new skill learning process. The ability to have attention to detail, especially if you're using the drones for scientific research, is really important. Making sure that you check that list and you've prepped the sensors and you've checked the drone and all those things. You know where you're flying, that you've filed all the paperwork, and that you're not going to get your knuckles wrapped for not having filled out a permission slip for all the various people who need to know what you're doing. But yeah, I think just the attention to detail and the enthusiasm is the key part, and just really enjoying what it is that you're doing. So promising opportunities for impact. I think there's such a wide variety, from things that we've touched on in this conversation already to, you know, delivery drones. I've heard about case studies of these drones being tested in Africa using medical supplies, and so enabling clinics out in the middle of nowhere to have a substantial supply of medicines or blood or whatever it is that they're needing. There's just fantastic use cases for the technology all over the place, and I think there's only going to be more. So there's a world of opportunity, I think, that's opening up, which is going to be really exciting to see.
Great, thank you, Becca.
I would love to second Becca's comment about the attention to detail, especially with the commercial licensure under Part 107. Aviation is all about attention to detail to make sure, and the thing is, the rules are there for a reason. I would say that if you are not a rule follower, this might not be the career for you. And that's okay. But it requires diligence because you're being entrusted with something that has the potential to seriously hurt people and damage property and cause all sorts of mayhem. And you don't have to look too terribly far to find that. When we had the CZU fires, there were instances where the drone equivalent of rubberneckers who slowed down on the highway to see what was going on, flew their drones, and caused and required firefighting operations to ground as a result of being an interloper. And it's that sort of that's like that when we're talking about community and sort of mutual respect, that's what we're hoping to foster and help teach and lead students to understand how they can participate in a way that is cooperative rather than and lets everybody accomplish their goals and work together to do the really neat stuff that we want to do.
Great. That's also excellent advice. Thank you, Steve. So I know we're almost out of time. Ethan Clark had a follow-up question. Justin, he wanted to know, how many applications have we normally been receiving for the program? And are there other UC campuses offering similar programs?
Yeah, well, this year we had our applications open for only about 3 weeks because we really, we received funding back in July, early August. And so we really did a mad dash to try to pull everything together. And so we only got about 26 to 28 applications this first round, but there's definitely a lot of interest on campus. And we're hoping that, now that we've gone through our first iteration with more time and students being able to share their experience, that number will greatly increase. And then I think that was a two-parter. Oh, other campuses. We are the first undergraduate, the campus to offer an undergraduate kind of training along these lines. I think there are some classes at UC Merced related to drones. And then again, the UC Drone Camp, which is a collaboration between UC Ag and Natural Resources, UCSC, UC Merced, and CSU Monterey Bay, is another great opportunity. And so we really want to encourage those of you who are interested to check it out. If you want to do virtual, the early bird special is $60. If you want to do the in-person, the early birds is around, I think, $400. And then the prices go up if you wait till after, I think, May 6th or 7th. So check out the website. We hope to see you at Drone Camp if you're interested. It's a great opportunity to learn, and especially if you're a beginner.
The other thing that I would add about Drone Camp is that if you're a student and you're interested, there is potentially some help with the fees as well. There are some scholarships available. Information's on the website, or email Michael or any of us, and we'll get you the information.
And I just put that link again in the chat. So I think we are at time. I want to thank our 4 amazing panelists for all of this insight and inspiration about this exciting field and tools. And I also want to thank Suze Howells and the Baskin team for all of their support in this event. And thank you all for coming. We really enjoyed sharing some thoughts with you.
I know.
Thanks for having us.